For decades, Israel faced one of the most serious challenges any country can face: a shortage of water. Much of the country is dry, rainfall is limited, and from the moment Israel was established in 1948, water was not just a natural resource. It was a national survival problem. The north had more rainfall and access to the Sea of Galilee, while the south, including the Negev Desert, had almost none. But the population was growing, agriculture needed to expand, and cities needed reliable drinking water. Israel had to find a way to move water from where it existed to where people needed it most. That challenge led to one of the most important engineering projects in the country's history: the National Water Carrier. The idea had been discussed even before Israel became a state. Engineers imagined a system that could take water from the wetter northern regions and transport it across the country to the dry south. After independence, that idea became urgent. Construction began in the 1950s, and the result was a massive network of canals, tunnels, pipelines, reservoirs, and pumping stations. Water was drawn from the Sea of Galilee, lifted by powerful pumps, treated, and sent south through a system stretching more than 100 kilometers. At the time, this was not just a water project. It was nation-building. Without it, many communities, farms, and cities in the dry parts of the country would have struggled to survive. For many years, the National Water Carrier helped supply farms, towns, and drinking water systems. It allowed Israel to grow crops in dry regions and support a fast-growing population. But over time, the pressure became too much. The Sea of Galilee became one of Israel's most important freshwater sources, but it was not unlimited. Droughts, population growth, agriculture, and regional water agreements all increased demand. By the early 2000s, it was clear that Israel could not depend only on natural freshwater. Then came a major turning point. Instead of only asking how to save freshwater, Israel began asking a bigger question: how can we turn seawater into drinking water? The answer was desalination. Desalination is the process of removing salt and minerals from seawater, so it becomes safe for people, farms, and industry to use. Israel had been studying this technology for decades, but the breakthrough came when reverse osmosis became more efficient and cheaper to operate. Reverse osmosis works by forcing seawater through special membranes. These membranes allow water molecules to pass through, but block most of the salt and impurities. What comes out on one side is clean fresh water. What remains is concentrated salty water. Israel began building large desalination plants along the Mediterranean coast. One of the first major plants was built in Ashkelon, and it became one of the largest of its kind at the time. More plants followed along the coastline. Together, these plants changed Israel's water story completely. Today, desalination supplies a major share of Israel's domestic drinking water. Water that once seemed unusable now flows into homes, cities, and industries. Instead of depending only on rainfall and lakes, Israel created a new source of water from the Mediterranean Sea. But Israel did not stop there. In 2022, the country launched an even more unusual project: sending desalinated water back into the Sea of Galilee. For centuries, the Sea of Galilee was a natural source of fresh water. But after years of drought and overuse, its water levels dropped dangerously low. So engineers built a pipeline system that could take treated desalinated water from the coast and move it inland toward the lake. This reversed the old logic. In the past, water was taken from the Sea of Galilee and sent to the rest of the country. Now, Israel can produce fresh water from the Mediterranean Sea and use it to help refill the Sea of Galilee during dry years. It is one of the first systems of its kind in the world, desalinated seawater being used not only for drinking, but also to protect and stabilize a natural lake. But desalination is only one part of the story. Israel also became a world leader in wastewater recycling. Instead of treating used water as waste, the country built systems to clean it and reuse it, especially for agriculture. A large portion of Israel's wastewater is treated and sent to farms, helping crops grow in dry regions without using fresh drinking water. This matters because agriculture uses a lot of water. By using recycled water for farms, more fresh water can be reserved for homes and cities. Israel also developed and expanded drip irrigation, a method that delivers water directly to the roots of plants through small tubes and drippers. Instead of flooding fields and losing water to evaporation, drip irrigation gives each plant just the amount it needs. This makes farming possible with far less water. Together, these systems created a full water strategy: move water across the country, turn seawater into drinking water, recycle wastewater, and use irrigation technology to reduce waste. The result is remarkable. A country that once struggled with chronic water shortages now produces enough water to meet much of its own demand, support agriculture, and even share water and water technology with other nations. Israel's water system is not perfect. Climate change, drought, population growth, and regional tensions still create serious challenges. But the transformation shows what can happen when engineering, long-term planning, and necessity come together. Israel did not solve its water crisis with one invention. It solved it by building an entire water network, from the Mediterranean Sea through desalination plants into pipelines, farms, cities, and even back into the Sea of Galilee. What began as a national weakness became one of Israel's strongest examples of innovation. And in a world where water scarcity is becoming more common, Israel's story shows that the future of water may not only depend on finding new rivers or lakes. It may depend on learning how to build them,